Boys and girls, this is Mr. Manise here again with another super cool video, and in this video I'm going to walk you guys through day 4 of our circles packet. I'm making this because I am not going to be here today, so I'm asking the substitute to play this video, me walking you through the entire lesson. So I need you guys to be paying attention because this is actually the toughest lesson in the entire circles unit. So make sure you don't let your mind wander. Okay, so we've only got this first page here. We've only got 3 different concepts, but you'll see that these problems can get pretty tricky, pretty math intensive in today's lesson. Okay, so so far we've talked about, in day 2, we talked about lengths of segments using Pythagorean theorem to find different parts of different lengths of chords and diameters and things like that. And then day 3, we changed it up to go to angles and arc lengths. Everything was in degrees. And now here we are back in day 4. We're back to physical lengths. Okay, so segments in a circle. We're going to be finding the physical lengths of these lines inside and around and outside the triangle. So we'll have units of meters, inches, centimeters, physical lengths. I think most of these problems don't have units, but sometimes they can. Okay, so let's go ahead and kick it off here. So our first concept here is when we have 2 lines that are intersecting inside the circle. Now this looks like yesterday's lesson, right? It looks like an interior angle, but we're not talking about angles. We're talking about segments. I'm trying to find a physical length. So my variable might be on this piece of this line or this piece of this line. Okay, so for this first concept here, we're going to call this, and make sure we can see all 3 of them in the camera here. We're going to call this one part times part. So write that down. Part times part. And I'm going to try to color code these. I'm going to use 4 different colors here. We're going to have this green segment here. Okay, I'm going to call that P1. That's part 1. And the second one, I'll use orange here. The other length across from this, the other part of this line segment, that guy, I'm going to call that P2. So we got part 1 and part 2. And then we have the other line over here. I will do this in blue, baby blue. We've got that piece. I'm going to call that part 3. And then the last piece in purple, I will call this guy, what do you think? Part 12? Nah, part 4. Okay, so camera's adjusted. So we've got part 1, part 2, part 3, and part 4. And the reason we call this part times part is because the formula is going to be quite simple. It's going to be part 1 times part 2. Okay, so the green times the orange, part 1 times part 2. That is going to be equal to, what do you think? Part 3 times part 4. Okay, yes. Part times part. Green times orange equals blue times purple. So I'll give you a second just to make sure you guys have that copied down. You don't have to do these in colors, but of course I'm a big advocate of using highlighters and colored pencils, especially in this unit. Okay, so that is concept number 1 of the day. And again, we're finding physical lengths. So if I have 3 of these 4 lengths, then I can plug it into this equation and find the 4th unknown segment. Okay, that is part times part. All right, number 2 is where it starts to get a little bit tricky. This is probably the trickiest of the 3. We're going to call this concept whole times exterior. Again, we're talking about line segments. Okay, so I'm going to color this the whole piece. I'm going to color this guy in orange, which is my second favorite color. Orange. I'm going to call this the whole piece. So you can put this little symbol there. That is the whole piece of that line. Okay, and then we have just the exterior piece, and I will do this in blue. Okay, so this little piece right here is the outside, this part of the segment that is literally outside or exterior to the circle. We will call that exterior, or I'll abbreviate EXT. Okay, that's the exterior. And then the other line segment is the exact same thing. So I've got the whole piece down here. And we can draw the symbol again. So that is the whole piece. And again, we've got the blue outside exterior piece. I'll label that EXT. Okay, whole times exterior. Okay, so our formula here is whole times exterior equals whole times exterior. And what that means is the left side, the whole piece, so the whole orange piece times just the blue piece, whole times exterior will equal this whole piece times this blue exterior piece. Okay, and they're not necessarily always going to be the same, of course. Okay, so whole times exterior equals whole times exterior, whole times exterior. All right, that is concept number 2. I'll stop for just a minute, make sure everybody has time to catch up writing this down. Okay, the third concept is going to sound difficult. In actuality, it's not very difficult. The third concept here is when I have a line that is tangent to the circle and I have a line segment that goes through the circle and meets to an exterior point. So in the whole times exterior, we just have 2 rays or 2 line segments. Actually, line segments, we don't have a ray. 2 line segments that are inside the circle. Here we have a tangent and a line. Okay, we're going to call this whole times exterior equals tangent squared. Whole times exterior equals the tangent squared. Okay, it's really not that bad. Okay, so I'll color the tangent in green. So that's my tangent line that touches the circle in one infinitesimal spot on the outside. And then once again, we'll go back to our whole times exterior. It's the same concept as the previous image. Okay, so here is my whole piece. And once again, I will have the blue exterior piece. Okay, so what this concept, this relationship with this formula says is the whole orange piece times the blue exterior piece is going to be equal to the green tangent piece squared. Okay, so we're down below the drawing here. We're going to write WE equals T squared. Okay, whole times exterior equals tangent squared. Okay, so let's go back. Let's review real quick. Part times part, P1, we're finding line segments inside the circle. Part 1 times part 2 equals part 3 times part 4. Green times orange equals blue times purple. Whole times exterior, the whole orange piece times the blue exterior equals the whole orange piece times the blue exterior. Whole times exterior equals whole times exterior. Whole orange piece times the blue exterior piece will equal the green tangent piece squared. Okay, so I've got a very funny little way to remember this. Okay, so I can already hear the laughter, precursor to the laughter. We're going to call this PP. Yeah, that's right, I said it. PP. This is a PP problem. PP, part times part equals part times part. Guess what we call this? Wee. PP, wee, wet. W-E-T. Okay, so feel free to laugh. That's fine. No problem. So here's the little saying. Okay, boys go pee-pee in the potty. Excuse me, let me start over. Scratch that, erase that from memory. Girls go pee-pee in the potty. Boys go wee. And if you're not careful, you might get wet. Yeah, I said it. Girls go pee-pee in the potty. Boys go wee. If you're not careful, you might get wet. Okay, so just like yesterday with our angles and our arcs. Okay, so it was all about the location of the vertex. Today, in this lesson, is all about which type of problem is it. Is this a PP problem? Is this a wee problem? Is this a wet problem? So you can start to see how these things will start to overlap. Students love to get the PP problem confused with the interior angle because they're saying, oh, the angle's inside. We're not talking about angles. We're talking about the length of a segment here, okay? PP, wee, wet. Okay, here we go. Let's jump right on into some problems here. Find X. The center is O for all of these problems. Okay, what kind of problem is this? It looks like an interior problem from yesterday. No, it's a new lesson. This is a what? This is a PP problem, okay? So, I'm not going to necessarily color code all of these, but I can say that, what, 9 times 6 is equal to 10 times X. Okay, so let's set that up. 10 times X, 10X is equal to 9 times 6. So we've got 10X is equal to 54. Divide by 10, and X is equal to 5.4. We don't have any units, so we'll just leave it as 5.4. Part times part equals part times part. Give you just a second to make sure you got that copied down. That's pretty easy. The PP problems are or the easiest, of course. Okay, number 2, what kind of problem is this? This is a wee problem. Okay, this one I am going to color code. Okay, so here we go. And this is where students get confused. So listen carefully, listen. Okay, whole piece is the whole piece. Students love to say 5 times 6. 5 is the exterior. Okay, yes, 5 is the exterior. However, what is the whole piece? The whole piece is the 5 plus the 6. Okay, so the whole piece is 11. Okay, so down here, what students love to say is, okay, they'll say 3 times x, okay, whole times exterior. But again, x is just the piece inside the circle, okay. So this whole piece that I'm kind of drawing here in orange, there's the whole piece. What is that whole piece? It's not x, it is x plus 3 is the whole piece. Okay, so if we go back to our wee, whole times exterior equals whole times exterior. Okay, so let's start with the bottom. I'll start with the bottom line. So it's going to be whole times exterior. Okay, so the exterior is 3. So I can set up an equation that says the exterior, 3 times the whole piece. The whole piece is 3 plus x. Don't write 3 plus x. Nobody writes 3 plus x. Write x plus 3. Okay, let me stop there and make sure everybody's comfortable with what I just did. The exterior, whole times exterior. The whole piece is x plus 3 times the exterior times the outside piece. Whole times exterior. Okay. That is going to be equal to, going up here, is going to be the exterior piece is 5. And the whole piece is what? 5 plus 6. Okay, I'm going to write it like that. I know we said it's 11. So just so you understand, the whole piece is 5 plus 6 times the outside exterior piece. Okay, let's go ahead and distribute. Look, this is what I'm talking about, guys. I'm the teacher, and I'm still doing this. I still do this, just to make sure I know that I am distributing to each term. Okay, 3x plus 9 is equal to 5 times 11, which is 55. And let's subtract 9 from both sides. I will get 3x is equal to 46. Divide by 3. And I will get x is equal to, that comes out to be 15.3. 15.3. Okay. I'll stop there and make sure you guys catch up. Whole times exterior equals whole times exterior. Set up your equation and then just solve for x. Okay, what kind of problem is number 3? That is a wet problem. Oh, they're nice to us. Pee, wee, wet. Okay, so this is an example of a wet problem. Okay, so we've got our tangent piece in green. We've got our whole piece, one of the best colors in the world, orange. So the whole piece, now what is the whole piece? It is x plus 5 is the whole piece. And then of course we got the exterior piece in blue. That is exterior. Okay, so let's set up our equation. Okay, whole times exterior equals tangent squared. I always like to write the whole part first. So the whole part is x plus 5. So we've got x plus 5, and then I'm going to multiply that times the exterior piece. I just like to set it up that way. Exterior times the whole. Okay, because I'm just more, it makes more sense than to put whole times exterior and put the 5 on the back end. We're just used to seeing that coefficient up front. But it's the same thing. That equals the tangent squared, 7 squared. Okay, so let me stop for just a second, make sure you're okay what I just did. The whole orange piece, x plus 5, whole times exterior, equals tangent squared. Okay, let's distribute. 5x plus 25 equals 49. Subtract 25 from both sides. And we get 5x is equal to 24. And weren't very nice to us, were they? Getting a lot of decimals. That's okay. The real world is full of decimals. 20 over 5 reduces to 4.8. Yes, technically it's fine to leave it as an improper fraction, but we're talking about segment length. So you tell me 24/5, that doesn't really have much meaning to me. You tell me that's 4.8, I say, oh, okay, x is about 5, so almost 5. Okay, so PP, wee, wet. All right, let's keep going. Now we're starting to mix it up a little bit. What kind of problem is number 4? Let's see if I can zoom in here just a touch. There we go. Maybe a little more. There we go. Is that more better? Okay. Number 4. What kind of problem is number 4? This is a PP problem, right? Part times part equals part times part. Okay, so I can set up an equation. I'll start with the 8 and the 2x minus 7. So I can say 8 times 2x minus 7 part times part equals part times part. 4 times x plus 10. Okay, let's distribute. 16x minus 56 is equal to 4x plus 40. And again, if we need to pause the video, you can pause the video, make sure everybody's caught up, make sure I'm not going too fast. All right, let's solve. Let's subtract 4x from both sides. Let's add 56 to both sides. And so I'm going to get 16 minus 4. I'm going to get 12x is equal to 40 plus 56, which is 96. I'm going to divide by 12. And finally, we get a nice round whole number. Now again, I'm not going to do this in the video, guys, but what should we be doing after the end of every problem? We should be going back and checking our work, right? So if we went back and plugged this in, this will be 18. If we plug in x here, that would be 16 minus 7. That would be 9. And we got to make sure that 8 times 9 is equal to 18 times 4. And it is. Okay. All right. Number 5. What kind of problem is this? I see a tangent line. So tangent square. This is a wet problem. Okay. So we're going to do whole. Again, what's the whole piece? The whole piece is x plus 2. Actually, you know what? Let's just be one of the problems that we let the students try to do on their own. So let's go ahead and pause the video here. Let's give the students a few minutes to work out this on their own, and then we'll pick it back up. Okay, so welcome back. So hopefully you guys were able to work this out no problem. So the whole piece is x plus 2 times the exterior. So the exterior times the whole is equal to tangent squared. And we distribute. I got 2x plus 4 equals 25. Subtract 4, 2x is 21, divided by 2, and hopefully you guys got 10.5. Okay, very good. All right, let's move on. Wet problems are pretty easy. Okay, what kind of problem is this? PP, that's another PP problem. Okay, so again, let's go ahead and pause the video. Let's give the students a few minutes to work on this, because you're going to see when we multiply 3x times 2x, we're going to get a quadratic. So go ahead and pause the video and we'll come back. All right, welcome back. So hopefully you guys didn't have much of a problem with this. I'm going to do part times part equals part times part. So if I do 3x times 2x, 3x times 2x is going to be equal to 9 times 6. So I've got 6x squared. That is not 6x, that is 6x squared equals 54. Now, technically I have a quadratic. How do I know that? Because the highest exponent is a 2. So I am in quadratic land 95% of the time. I'm going to have 2 answers to my quadratic equation. Okay, but what method is best to solve this? Okay, we don't have a trinomial. We're not going to be trying to factor this when a equals 1. Look up there on my sheet on the wall. What is item number 3? The third method for solving quadratics is the square root method. And that is when you don't have the b term. We don't have a bx term. All we have is the x squared term and the c term, the constant. So this is the square root method. All you got to do is get x squared by itself. Okay, so we're going to keep the 54 on that side. We're simply going to divide by 6, and I get x squared is equal to 9. Okay, and then I'm going to take the square root. Guess why we do that? Because it's the square root method. Yes. We're going to isolate x squared, and we're going to take the square root. So when I take the square root of 9, I get x is equal to 3. Yes, that just happened. I just hit the bell. That's right. X is not equal to 3. What is x equal to? Technically, it is plus or minus 3. Guys, you can have negative variables, but we got to go back and check and make sure we don't have negative angles, negative lengths. If I take negative 3 and plug it back in there, I've got a negative length. So I cannot have that. So the only answer that works is the positive 3. Okay. So if you said x is 3, you got lucky because it could be -3 as well. You just have to check it. All right. Okay, that's another PP problem. Okay, are you guys ready? Are you ready? Are you ready? Please say yes. I hope you say yes. These are tough, guys. Okay, these are some challenging problems. All right, so math is a little intensive here. We're going to have some quadratic equations. That's okay. Number 7, pretty tough question. Make sure I've got enough room here. Scooch this back just a little bit so we got plenty of room. Okay, here we go. Number 7. Okay, this is what kind of problem is this? This is a wet problem, right? Because I have a tangent. So whole times exterior equals the tangent squared. Well, what is this exterior piece? We have this line that is x. So this whole length is x. Okay, and then this piece inside the circle is 10. So what is the exterior piece? I'll give you just a second to think about it. The whole length is x. Just this piece is 10. So the blue exterior piece is what? The whole minus the little. So this blue exterior piece is actually going to be x minus 10. Okay. So now we've got whole times exterior equals tangent squared. But check this out. When I do whole piece, what is the whole piece is, we already know it's x. I mean, they just gave it to us. Okay, but if you didn't recognize that or see it, if I add this piece plus that piece, x minus 10 plus 10, the 10s just cancel. Okay, I'm left with x. So the whole exterior piece, exterior x, times the whole times exterior. Okay, what is the whole piece? X times the exterior piece is the x minus 10. Okay, let me stop. Make sure y'all are okay with that. I can see how that might be a little bit confusing. So normally I write the exterior times the whole, but this problem is actually backwards because the x is the whole and the x minus 10 is the exterior. But I'm still going to write it like this because I don't, again, if I put the x on the back end, it doesn't really make sense. We're not used to seeing it written like that. Okay, so hopefully you guys understand what just happened there. Okay, the whole piece x times the exterior is equal to the tangent squared, which is 8 squared. Okay, now we got to solve this equation. So let's distribute. X times x is x squared minus 10x equals 64. All right, I want to have my quadratic set equal to 0. So we got x squared minus 10x, move the 64 to the other side, minus 64 equals 0. Okay, now what is the best method to solve this quadratic? Okay, there is no GCF. It's not a special case because that's a negative. That would have to be a positive 64 for me to consider it being a perfect square trinomial. I can't do this square root method because I do have a b term. So now I'm up to factoring, option number 4 on my wall. Can I factor this when a equals 1? Yes, a equals 1. What are the factors of negative 64 that add to negative 10? So I'm basically looking for two numbers that multiply to give me 64 but are 10 apart from each other. Well, what if we use this little trick that I showed you guys the other day? Y equals, I don't care about it being negative, just type in 64 divided by x, and let's go get some factors of 64. Second table, and let's look at our table of values. These are all the factors of 64. So I'm looking at two numbers that are 10 apart from each other. No, no, no. Ugh, yikes. There aren't any. Okay, so I cannot factor this when a equals 1. Obviously, I can't factor when a is not 1 because a is 1. Okay, what are the last two things on the wall over there? We're now reduced to either the quadratic formula or completing the square. Okay, if you wanted to complete the square, this is the only quadratic method of solving where you don't want it set equal to 0. I'd have to move the 64 to the right-hand side. I'd have to draw my plus blank, plus blank. I'm not a big fan of completing the square. I prefer to use the quadratic formula, although this would be a good candidate to complete the square because I always tell my students don't ever try to complete the square when a is not 1. Okay, because when you complete the square, a must be 1. Okay, so if this were like a 2 or a 12 or something, no, I'm just going to do the quadratic formula. This one, I could probably complete the square just as fast as using quadratic formula, but you guys are probably more comfortable with quadratic formula, so that's what I will do. When I teach the quadratic formula, I'm a huge advocate of coming out here and listing what are your A, B, and C values. List them out. What is my A? There's an understood 1 right there, so A is 1. My B term is the negative 10. It's not 10, it's negative 10. My C term is the negative 64. Okay, so I'm going to come over here and I'm going to start the quadratic equation. Quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. Yes, we have that lovely tune. Okay, it's a little tricky though when the b is negative. Okay, so when you write these numbers down, you don't have to do any more thinking. You just plug and chug, plug them into the formula. Now b is negative b, but my b is negative. Okay, so I'm going to write that out twice. Negative 10. Yes, that makes it a positive. Plus the square root of b squared. Now here, when that b is negative, here's where students love to make a mistake. They will write negative 10 squared. Please, please, please do not do that. You cannot do that, guys. Negative 10 squared. You cannot do that. Your calculator spits out negative 100 because it does order of operations first. It is going to square, right? Please excuse. Okay, there are no parentheses, and it eschews exponents. It's going to square the 100, and then it's going to make it negative. You cannot do that. So anytime you square a negative value, okay, when you raise it to an even exponent, you've got to put that in parentheses. Negative 10 squared is your positive 100, okay? So when I write this out, I put in parentheses, negative 10 squared. Please, please, please put that in parentheses. This will save your life. The rest of geometry will save your life in advanced algebra next year, okay? Because we're going to be doing something raised to the 4th power, to the 8th power, to the 12th power. You need to get in the habit of putting that stuff in parentheses. Now, if you're raising it to an even power, then yes, it doesn't matter because anything raised to an odd power will still be negative, okay? But evens, we need to put in parentheses. Okay, so we got negative 10 squared minus 4ac. So minus 4, okay? I put this in parentheses, minus 4 times a, which is 1, times c, which is negative 64. Okay, all over 2 times a, or 2 times 1. Okay, students love to make this quadratic formula so much more complicated than it is. Okay, when I do this, guys, I always do my discriminant first. Okay, you cannot type all of this into your calculator in one swoop. You can't do it because there's a plus or minus there. So when I do this, this is what my brain sees. I'm only looking at the discriminant, which is just the part inside the radical. Okay, I want to do that part first on my calculator. So I want you to type it in your calculator exactly the way that you see it. Okay, so what do I see? I see parentheses, negative 10 squared. Type in exactly what you see. Minus 4 times 1 times negative 64. Okay, and I get 356. That's what's inside the radical. Okay, so I stop there. Okay, I kind of break it down into little bitty steps. Don't be trying to do all this stuff in 1 or 2 steps. Break it down into little steps. Negative 10 makes this a positive 10. So we've got positive 10 plus or minus the square root. Now don't forget, the discriminant is just the number inside the radical. The radical doesn't go away. So we got 356. So it's the square root of, whoops, that's a little bit of a mistake. 356. That's more better. All over 2 times 1. Okay, so our answer is 10 plus or minus the square root of 356 all divided by 2. But notice, well, first of all, let's check and see if 356 is a perfect square. The square root of 356, rats. It's not a perfect number, okay? So it's going to be some decimal. All right, so we need to break this down and figure out what are the 2 solutions. 95% of the time in quadratic land, you have 2 solutions. Okay, so the first solution is going to be 10 plus the square root of 356 over 2. Now, when I type this into my calculator, here's how I'm going to do it, guys. I'm not even going to round this number. I like to keep this stuff. Anytime you round early in a problem, it's always going to hurt you. Okay, it's going to make your answer less accurate. Okay, so if you can avoid that, it's always best to do that. So instead of just rounding this to say 18.9, let's keep this number. I'm going to do 10 plus this value. Okay, so I'm going to go, and then I'm going to divide this by 2, but I got to put this in parentheses as well. So I'm going to do parentheses, second answer. Okay, all right, so again, the second answer is down here above the minus sign there. I could start with 10. I can do it this way too. Let's let the camera refocus. Come on, you can do it. I love it when it does this. There we go. Okay. So I could actually start with parentheses 10 plus my second answer. All I'm doing, guys, is I'm saying 10 plus this 18 point something number, close the parentheses, divided by 2. Okay, now why do I have to have parentheses? If I don't have parentheses, if I just do 10 plus second answer divided by 2, it's going to take the 18 and divide it by 2, and then it's going to add it to 10. Again, order of operations. Please excuse my dear Aunt Sally. So I've got to put that stuff in parentheses. Press enter, and I get 14.4. So one of my answers, 10 plus root 356 over 2, that's going to be equal to 14.4. Okay, my other answer is going to be 10 minus the square root of 356 over 2. Okay, so I do parentheses 10 minus, now this time I'll just go ahead and type in the square root of 356. Now if you do it this way, you need to close 2 sets of parentheses. The parentheses around that 356 and then the parentheses around the first set of parentheses that I have. I know you guys are probably thinking, oh my gosh, all these parentheses. Guys, I'm here to tell you this is what it's going to be like in college in the real world. Everything is done based on parentheses. I did problems in college where it was 6 sets of parentheses. Okay, so I'm trying to introduce this now to you so you'll be more equipped to handle this kind of stuff in college. Okay, divided by 2. All right, that's going to give me negative 4.4. Okay, let me do that one more time because I know I might have gone through that a little bit fast. Let me do that again slower. Okay, so the first one is 10 plus the square root of 356 over 2. So if you just wanted to get that number first, type in the square root of 356. I want 10 plus that number, 10 plus second answer, divided by 2. That gives me that first number. So one of my solutions might be 14.4. Let's do it the other way. Square root of 356, I take that number. I'm going to do 10 minus that number. So 10 minus second answer. Now this time I only need one set of parentheses, divided by 2. That gives me that negative 4.43 number. Okay. Now, what do I always need to do? 95% of the time I have 2 solutions to my quadratic. This time I do have 2 solutions, but when I plug it back in, what happens when I plug in negative 4.4 for x? I can't have a negative length, right? Okay, so the negative 4.4 doesn't work. So my only solution to this problem is x is equal to 14.4, the positive value. Okay, that's a lot. All right, this next one, number 8. It's not any easier. Okay, so what kind of problem is this? This is a wee-wee problem, right? Whole times exterior. Okay, I'm going to have to go through this in a little bit faster and make sure this video doesn't go over the 50-minute mark. Okay, the whole piece times exterior. Okay, what is this whole piece? The whole piece is x plus 8, and the exterior is x. So the exterior times the whole piece is x plus 8 equals the exterior piece 5 times the whole piece. What is the whole piece? 5 plus 7. That's 12. Okay, so when I distribute here, I've got x squared plus 8x equals 5 times 12, which is 60. Okay, let's move the 60 to the other side. X squared plus 8x minus 60 equals 0. Okay, I've got a quadratic. What are the factors of 60 that add to 8? 60 divided by x, second table. I need 2 numbers, okay, that are basically 8 apart from each other. No, that's 11 apart, 7 apart, 4 apart. 4 apart, so, don't have any. So guess what? Guess what we got to do? We got to use quadratic formula again. Okay, so again, I'm going to go through this a little bit faster. A equals 1, B equals 8, C equals negative 60. All right, this time the B is positive, so that helps a little bit. So it's negative B, so it's negative 8 plus or minus the square root of B squared. This time I don't need parentheses because I can just say 8 squared because it's positive. Minus 4 times A times C all over 2 times A. Okay, so I've got the negative 8 plus or minus. Let's do the discriminant in our calculator exactly the way you see it. Okay, so we have 8 squared minus 4 times 1 times negative 60, and that gives me 304. Okay, so I've got negative 8 plus or minus the square root of 304 all over 2. Now, is 304 a perfect square? Square root of second answer. No, it's not. Okay, so once again, we're going to need some decimals here. Okay, I'm not going to go through the nitty-gritty of what I just did. Okay, so I just taught you guys how to do that. There's the bell for the end of my planning period, but this is only 35 minutes, so I still got some time. I'm going to try to make this video maybe about 45 minutes or so. Okay, so we got -8 plus or minus the square root of 304 over 2. So the first answer is going to be parentheses -8 plus second answer divided by 2. That gives me 4.7. Okay, so x is equal to 4.7. And then the second answer, okay, when I do the square root of 304, that's that number again. The second answer is going to be parentheses -8 minus second answer divided by 2. And that gives me -12.7. Okay, does the negative work? No, can't have a negative length. So x is equal to 4.7. Okay, you guys are going to love this last problem. You're going to have to write kind of small. I'm sorry, there's not a whole lot of room here. Last problem, what kind of problem is this? This is a PP problem, right? Part times part equals part times part. Okay, so let's start off with the 3 and the x minus 4. Once again, if we need to pause the video to slow things down, that's no problem. Okay, so part times part. So we've got 3 times x minus 4, part times part, equals part times part. So we have x minus 4 times x plus 2. Okay, so when I distribute here, I've got 3x minus 12. Again, I have a feeling I'm going through this a little bit fast, so I'm trying to be conscious of slowing down, make sure you guys have time to copy all this down. All right, 3x minus 12 equals, now what do I do with these two? When I have a binomial times a binomial, what is that magical 4-letter word that starts with F? Yeah, that's not, I know what you guys are thinking. FOIL. FOIL is the word. Okay, so first, x times x, x squared. Outside, x times 2, 2x. Inside, -4 times x, minus 4x. And last, -4 times 2 is minus 8. Okay, so we got kind of a long equation here. Let's go ahead and simplify our like terms. So I have 3x minus 12 equals, I can combine these. I've got x squared, 2x minus 4x is minus 2x, and then minus 8. All right, so I need to get all this to one side of the equation. So I need to subtract 3x from both sides. I need to add 12 to both sides. So I will have x squared. If I subtract 3x from both sides, it's going to be x squared minus 5x. And if I add 12 to both sides, a positive 12 minus an 8, I'm going to have plus 4 equals 0. Okay, so let me stop there for just a second. Make sure you guys are with me. Subtract, move the 3x to this side. So it's going to be -3x minus 2x minus 5x. Add 12 to both sides. -8 plus 12 is 4. And now I've got my everything set equal to 0. All right. Can I factor this one? Are there any factors of -4, or excuse me, are there any factors of 4 that add to -5? The two pairs of numbers that pop in your head are 2 and 2 and 1 and 4. Well, will 1 and 4 get me to a 5? Yes, it will. Okay, so what are the factors of positive 4 that add to -5? When the C value is positive, both have to be positive, both have to be negative, and since the middle term is negative, they both have to be negative. So I'm going to draw a little arrow right up here and say that this is going to factor as they're both negative. So this is going to factor as x minus 1 times x minus 4 equals 0. Sorry, there's not a lot of room. All right, can I do flippy flip? Yes, I can, because there's an understood 1 in front of the x. So if I flip both signs, I get x is equal to 1 and 4. Okay, so are we done? Nope, not done. Okay, we got to check and make sure these work. If I plug in a 1, 1 minus 4 is -3. That doesn't work. If I plug in 4, 4 minus 4, that's 0. I can't have a length of 0. That doesn't work. So guess what, boys and girls? The answer to this problem is NRS. No real solution. There is no number on planet Earth that you can stick in for x that will make this problem true.
Students, at this time, you should be exiting the building. All students need to be exiting the building at this time.
Yeah, y'all don't need to exit the building. Y'all need to stay right where you are. Okay, please don't exit the building. Okay. All right, so that's it for this video. Hope you guys are able to kind of work through this and see this. Some pretty complicated problems here, some complicated math. But let's just go back and refresh our memory. Let's go back and summarize. We've got three different things. We're always talking about segments in the circle. We got PP, part times part equals part times part. Wee, whole times exterior equals whole times exterior. Wet, whole times exterior equals the tangent squared. Okay, so please, 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 guys, make sure you are doing your quiz is. If there's any time left in the class after this video, get out your cell phones, go ahead and start working on that quiz is so you can stay fresh and abreast of these concepts. All right, that's it for this video. We will see you on the next one.